Hello dear students, I welcome you all to my channel. So let us continue with the series of questions on probability. Okay, so the first question for the day is question number 6, and let me read the question for you. So question says, if A and B are two complementary events, then what is the probability or what is the relationship between P of A and P of B? So P of A stands for probability of event A occurring and P of B stands for probability of event B occurring. Okay, so we need to find what is the relationship between P of A and P of B. Okay, so first let us understand what is the meaning of complementary events. So in order to understand this particular topic, let me take one random experiment, and the experiment is tossing a coin. Okay, and the event here is, event means my desire, I want to get heads. Okay, so let me call A to be event of getting heads. Okay, now the B is complementary of A, right? Okay, so the event B will be not getting heads. Okay, so it is against your desire. Okay, so such kind of events are called complementary events. So they are going to be exactly opposite to each other. All right, so that's what is the meaning of complementary event. And if you remember, the first problem that we did in this particular exercise was also for complementary events. Okay, so the relationship here will be when you add such probabilities. Okay, so remember, when you add the probabilities of complementary events, then you will always get 1. Okay, so your relationship between P of A and P of B will be, the sum of these two will always be 1. Okay, so let me repeat once again, the sum of the probabilities of complementary events will always be equals to 1. Okay, so this is our first answer. So let us see the second part. So second part says, if the probability of happening of an event is 0.46, now what is the probability of event A not happening? Okay, so it's again just opposite of happening, right? So suppose event A happens, okay, and not happening is your complementary event, right? So what I can say here is probability of event A happening is given to be 0.46. Okay, so let P of B represent the probability of event A not happening. So that means since A and B are complementary to each other, so the sum of them is going to be 1, right? Okay, so we want to find P of B, probability of event A not happening, right? So let us take this P of A there. So we have P of A equals to 0.46. Put the value and subtract. So event A not happening, see P of B is equals to 0.54, right? And we know that P of B is the probability of not happening of event A. So that's why my answer for this particular question is going to be 0.54. So you may pause the video to note down. Okay, let's have a look at the next question. So in question number 7, in a TT match between Geeta and Ritu, the probability of winning of Ritu is 0.73. Find the probability of winning of Geeta. Number 2, not winning of Ritu. Okay, so let me take the case out here. So winning of Geeta is a complementary event to winning of Ritu, isn't it? Right? So both are exactly opposite to each other. So that's why they are complementary events to each other. All right. So what is given to us? Probability of winning of Ritu is given. So we know that probability of winning of Geeta is complementary. So that's why probability of winning of Ritu plus probability of winning of Geeta will be equals to how much? It will be always equals to 1, because the sum of the probabilities of complementary events will always be equals to 1, right? So that's why we have this equals to 1. Okay, and we need to calculate probability of winning of Geeta, right? So we need to calculate probability of winning of Geeta. So we know what is the probability of winning of Ritu, which is given to be 0.73, right? So let me take this over there. So let me put the value. So it is 0.73. So 1 minus 0.73 is 0.27. So my first answer is 0.27. Now the next thing is not winning of Ritu. It is given that Ritu wins, and here you are finding just opposite of that, right? So again, this particular event and this particular event, they are also complementary event. So that's why I have there some probability of those event occurring. Okay, so sum of the probabilities of those event occurring will be equals to 1. So we need to calculate this. We will take this to the right hand side, put the value, and your answer will be 0.27. Alright, so you may pause the video to note down. Okay, so there is a question 8 which has the same question like question number 7. Okay, so you will try this question number 8 by yourself. Okay, so let's talk about very important topic for the day, that is sure event. So something which definitely happens. Okay, for example you can take, okay, so getting a number less than 10 in throwing a die. Okay, so definitely you get a number which is less than 10 when you throw a die, right? So such kind of events are known as sure event. Okay, now impossible event, so event which never happens. Okay, so for example, getting a 6 while tossing a coin, is it possible? You will get either heads or tails, you will never get 6, right? So that kind of event is known as impossible event. So that means a sure event is something which definitely happens. So that's why the probability of sure event happening is always equal to 1. Okay, so you need to remember this thing. An impossible event is the one which never happens. So the probability of such event happening is always equals to 0. Alright, so these are the two very important results which will be useful in the upcoming problem as well. Okay, so you may pause the video to note down. Okay, so let's see question number 10 and 11 combined together. So in this question says, in a single throw of a die, find the probability of getting. Okay, so there are many questions, I'll take only few problems from there, you will do the rest by yourself. Okay, so for this let me write the sample space. So in the sample space we have all possible outcomes, right? And what are the possible outcomes of a die? So the possible outcomes will be 1 2 3 4 5 till 6, right? And how many elements are there in this? We have got 6, so that's why number of elements in the sample space is equals to 6. All right, so the first question is event of getting 5. So how many 5s you can see out here? So you have only one, so that's why we'll write only this much. Okay, because you want to get this, right? So you want to get 5, so that's why this becomes my event. So how many elements are there in this particular set? We have got only 5, so that's why n of e, number of elements in e, will be equals to 1. So the probability of getting a 5 will be, according to the formula, it is ne by ns, right? So what is ne? Ne is 1. What is ns? Ns is 6. So my answer will be 1 by 6. Okay, so let's see the second part. So second part says we want to get 8. Okay, so is this possible to get 8 when you throw a die? No, right? So you will get 1 2 3 4 5 or 6. So any one of them you will see, but you will never see 8. So this becomes your impossible event, right? And we know that probability of impossible event will always be equals to 0, right? So that's why my answer for this particular question becomes 0. So you may pause the video to note down. Okay, so the third part says that we want to get a number less than 8. Now when you throw a die, it's for sure that you will always see a number which is less than 8. So that's why this becomes your sure event, and we know that probability of sure event happening is always 1. So my answer for this number 3 will be equals to 1. All right, so let me take question number 4. Okay, so you want to get a prime number, and out of 1 2 3 4 5 and 6, these are the only prime numbers. Okay, so 2 3 and 5. So how many elements are there in this particular set? So there are 3 elements, that is 2 3 and 5. So that's why n of e will be 3. So that's why probability of getting prime number is ne by ns. Ne is 3, ns total number of elements in the sample space is 6, so 3 by 6 is half. So my answer for this particular question becomes half. Okay, so let me take the last part, that is question number 7. So you want to get a multiple of 3. All right, so let us see what are the multiple of 3 in this. So we have, okay, so e, event E is the event of getting even number. Okay, so you want to get even number or a multiple of 3. So even numbers. So let us see what are the even numbers first. So 2, 4 and 6 are the even numbers, and the multiple of 6 are 3 and 6. So 6 is already there, so we need not put that number in this particular set. Okay, so 3 will also come in the set. So altogether how many elements are there? So there are 4 elements in this particular set. So that's why n of e becomes 4. So that's why my probability will be ne by ns, which is 4 by 6. Do the cancellation, so your answer will be 2 by 3. So I have not done few problems, for example 5 and 6. So you will do 5 and 6 by yourself. Alright, so with this we close for the day. Thank you very much.